All right, everyone, 4.5 quiz review problems. Let's review some trig integration by substitution. Let's do numbers 48 and 50. You had to do 48, 49, and 50, but we'll just do two of them. So you need to figure out what you need to set u equal to. So you always want to choose your u so that when you do its derivative, you get what else is left in the original integral expression. So here, we want our u to be x to the fourth, okay? Because when you do its derivative, when you do du, derivative of u, derivative of x to the fourth is 4x to the third dx. And that's precisely what else is left in the integral, this piece and this piece right here and here. Those are your du. So I know you're probably thinking, okay, what about the sine expression though right here? Well, that is just going to stay in the integral as sine of u. Sine of u du. That's our new integral. Now, we don't have to accommodate for the sine with our u because we could just leave the sine in the integral and then just integrate it. We just find the antiderivative of sine, which is negative cosine, right? Derivative of cosine is negative sine. So the derivative of negative cosine is positive sine, which means if you think about that in reverse, the integral of sine is negative cosine. So our integral, our antiderivative of sine is negative cos of u plus c. And then finally, you just plug back in for your u expression. Our u was x to the fourth. And there you have it. That is your integral. If you ever want to check this, do the derivative of this thing. The derivative of negative cos is positive sine, right? Now, when you do a derivative of a trig function, you have to use the chain rule, which says leave the inside alone and then multiply by the derivative of the inside, which is going to be 4x to the third dx. And that's exactly what we have in our original expression, in our integral, in the question at hand. That's just our check step. You don't have to do that step, but that's how you would check it. You would do the derivative of your antiderivative, and you should get back your original integral. Okay? Number 50, cosine of 8x. Let's move this over here. So here, our u is just going to be the 8x. It's just this inner piece here. Du, derivative of 8x is 8 dx. Well, the problem is we don't have an 8 there. We just have a dx. It's actually a 1 is what it is. This is actually a 1. So we have 1 dx. We need it to be 8 dx. Or, I'm sorry, we need 8 dx to turn into 1 dx. We have to replace everything in our original with stuff about u and du. So we need to get this 8 out of here and turn it into a 1 by dividing. Now we have a precise match. We have 1/8 du equals dx. So this integral is going to become cosine of u times 1/8 du. That will account for the cosine, the 8x, and the 1 dx there. So the key step in this whole problem was making sure we have that 1/8 factor in there. Because our derivative, when we did derivative of u, became 8 dx, but we only needed to be a 1 dx. So we had to divide that 8 out of there. Then we just do the integral of 1/8 cosine, which is really just going to be 1/8 sine of u plus c. And then we would plug back in our u expression. That's it. Done.